This is CPE 133. This is Introduction to Hardware Description Languages, which is commonly known as HDLs. This is Chapter 1 of the Free Range Verilog Foundation Modeling text. And keep in mind that this chapter is about HDLs in general, but we will be using Verilog in CPE 133. So there's two main types of hardware description languages out there, which would be VHDL and Verilog. Once again, we'll be using Verilog. These hardware description languages have one purpose, and which is to model digital circuits, which is another way to say describe digital circuits. So once you generate that model, there's two things you can do with it. One, you can synthesize it, which generally means change it from one form to another, which you're going to write it in text, and it's going to end up in some other form, whether that be on an actual piece of silicon, or what we're going to do in this class is we're going to implement our circuits on a programmable logic device, which is going to be an FPGA on the FPGA-based development board. So the other thing you can do with your model, and we're going to use this also, is verification, and that means essentially you're going to write a model that describes a circuit, and then you need to test that model, and you're going to use Verilog to both design the circuit and test the circuit. And if you delve deeply into it, you'll see that Verilog was actually started out as a verification language. So hardware description languages, they look and feel like programming languages, but you got to be really careful with this. So when you're programming a computer, you're writing code, which is essentially instructions, and those instructions are going to be executed by like a finite number of processors, typically one. And essentially what's going to happen is one instruction at a time is going to be executed by that processor. So modeling digital circuits, completely different. The code looks the same, but you're writing code that's going to describe a digital circuit. And keep in mind, with a digital circuit, you can have a whole bunch of different things happening at the same time. It's not limited to just one stream of stuff happening. You're going to design a circuit where many things are happening in parallel or simultaneously. So the point being is that there's a huge difference between a hardware description language and programming code, and don't ever think they're different. If you start thinking they're the same, you're going to run into problems. So the general thing we're going to do here is work with the synthesizer, and the process we're going to use is we're going to write some HDL code, which we're going to use Verilog, which is just text-based code. We're going to send that code off to another piece of software that we call the synthesizer. Synthesizer magically puts it into another format, generally makes it work in actual hardware. So it seems magic, but it's not. It is a relatively complex process. The idea is it's not really complex for us because the software, pre-existing software, does most of it for us. So once again, the synthesizer is a piece of software that's going to do most of the work for us. Now, if you think about it, it's going to take a text description of a digital circuit and generate a digital circuit. And so there's a lot of magic that goes on there. And one of the problems is you want to be able to control exactly what that synthesizer does. So essentially what we're going to do is keep our models, HDL models, as simple as possible to give the synthesizer as few options as possible. And the benefit of this is the fact that if you write simple models, they're going to be easier to write, for number one, and they're also going to be easier to test. Now, testing is part of the process. So the key here is to getting your models to work is controlling the synthesizer. Okay, so a couple things to follow here to control that synthesizer. Essentially, you need to understand the basics of digital design. Digital design, not overly complicated. It's based on just a few basic circuits. Even the most complex circuit is a conglomeration of these simpler circuits. You also need to understand the basics of the HDL you're working with. In our case, that would be Verilog. Not a lot to it. Verilog's an intense big thing, but for a beginning digital design course like this, we're not going to delve too deeply into it. So there's not a whole lot you need to know, but you do need to know something. So generally think what we're going to do here is we are going to keep our models as simple as possible, and we are not going to rely on the synthesizer to generate a working circuit for us. Our mission here is to control the synthesizer and not give it free rein, such as, here, go generate this giant digital circuit for us. It's going to disappoint you every time. The other thing we want to do here is follow the general digital design paradigm, which is not make a giant circuit, make a lot of little circuits that talk to each other. So keep it simple, keep it modular, keep it hierarchical, design a lot of simple circuits that talk to each other as opposed to one giant circuit. So accordingly, these are the 4 golden rules of modeling a digital circuit with a hardware description language. You got to keep the models as simple as possible. This is make it more doable, more testable, and it also leverages kind of the notion of modularity and hierarchicalness in digital circuits anyway. Don't rely on the synthesizer to generate a circuit for you. The synthesizer has issues, then the issues become greater as your models become more complex. So you should also kind of have an idea that once you design something, you're going to need to test it. So once again, that kind of says keep your models as simple as possible and as modular as possible. It's going to help you test those circuits kind of individually, as opposed to testing just giant circuit that does a whole ton of things because you sent a complex model off to the synthesizer and it gave you back a piece of junk. Lastly here, neatness counts in generating these models. The idea is the synthesizer really doesn't care what your models look like so long as the syntax is correct, but other humans reading these, namely yourself, is going to have to maybe go fix these, modify them, particularly if they have problems, and once you debug it, you got to fix it. Anyway, organized, neat models are the way to go. It's going to help you design working circuits, and certainly going to help you test circuits. So in summary, there's 2 HDLs out there, hardware description languages, which is Verilog and VHDL, and typically we use those to model digital circuits. We also use it to verify digital circuits as well. Synthesizer is this really complex magic thing. Essentially, it's a piece of software that takes your text description of a circuit and generates, translates it to another form. Eventually, it's going to help us implement that text file as a working circuit on a development board. So the way we're going to make this work is by controlling what the synthesizer does. Typically, we're going to do that by understanding digital design in general. Keep things simple, keep things modular. Understanding basic HDL concepts, which once again is going to help us keep the synthesizer under control. And we're going to keep our models as simple as possible. We're going to use many simple models that talk to each other as opposed to one giant module that does everything we think it needs to do.